All matter in the universe, from the vastness of outer space to the tiniest microorganisms on Earth, is composed of incredibly small units called atoms. Atoms are the fundamental building blocks of all substances, carrying the unique physical and chemical properties that define each element. They are indivisible by chemical means. Breaking them apart destroys their identity. Despite their minuscule size, atoms have an intricate structure that governs their behavior and interactions. At the heart of every atom lies a dense nucleus containing protons, which are positively charged, and neutrons, which carry no charge. Orbiting the nucleus are electrons, tiny particles with a negative charge that move in organized regions called electron shells. The number of protons in the nucleus determines an atom's atomic number, which distinguishes one element from another. For example, hydrogen, the simplest element, has an atomic number of 1, while carbon, an essential element for life, has an atomic number of 6. The sum of an atom's protons and neutrons gives its atomic weight, an important factor in understanding the behavior of different elements. Atoms are electrically neutral because the total positive charge of protons in the nucleus is balanced by the total negative charge of electrons surrounding it. However, variations in the number of neutrons create different isotopes of the same element. For instance, oxygen atoms always have 8 protons, but they can exist with 8, 9, or 10 neutrons, giving them atomic weights of 16, 17, and 18 respectively. These isotopes can have significant applications in science, from medical imaging and treatments to carbon dating and sterilization. While the nucleus of most atoms remains stable, the electrons in the surrounding shells are responsible for an atom's reactivity. Electrons are arranged in shells at increasing distances from the nucleus, and each shell has a specific capacity. The first can hold up to 2 electrons, the second up to 8, and the third up to 8 if it is the outermost shell. When an atom's outermost shell, known as the valence shell, is filled, the atom is chemically stable and less likely to react. This is the case with noble gases like helium and neon. In contrast, atoms with incomplete outer shells tend to interact with others, either by sharing, donating, or receiving electrons in chemical reactions. These interactions form molecules, the foundation of all chemical compounds. The periodic table organizes elements based on their atomic structure, highlighting their similarities and differences. There are 92 naturally occurring elements, but only about 26 are commonly found in living organisms. Among these, hydrogen, carbon, nitrogen, and oxygen are the most abundant and essential for life. Their unique ability to form stable bonds makes them the backbone of biological molecules like DNA, proteins, and carbohydrates. Sodium, calcium, phosphorus, and iron also play crucial roles in maintaining life processes, from nerve function to bone formation and oxygen transport. The chemical properties of these elements are dictated by their electronic configurations, the way electrons are distributed across their energy levels. When atoms interact, they form chemical bonds, which are the forces holding atoms together in compounds. These bonds can be ionic, where electrons are transferred from one atom to another, or covalent, where electrons are shared. The type of bond formed is influenced by the number of valence electrons an atom possesses. The study of atomic structure is not just a topic in chemistry textbooks, it is the key to understanding the universe at a fundamental level. The intricate relationships between protons, neutrons, and electrons dictate everything from the behavior of simple gases to the formation of complex biomolecules essential for life. As scientists continue to explore atomic properties, new discoveries in medicine, technology, and energy emerge, reinforcing the incredible impact that these tiny particles have on our world. If you enjoyed this journey through time, be sure to like, subscribe, and hit the notification bell for more amazing science content. Thanks for watching, and see you next time.